So first of all, welcome to the Merantix AI Campus. I'm Luka. I'm part of the investment team at Merantix Capital, and we're very excited to co-host this event with Cathay Innovation. And with that, I'll hand it over to Costanza.
Thank you very much. Welcome everyone. Very excited to be here as the Cathay Innovation for the second time in a row, seeing breakfast with Merantix. Always a very exciting community. I would like to invite the panelists, Ivan and Nina, to join me on stage. And I will start with a brief introduction about myself and Cathay, and I will introduce the panelists as well. So, myself, I've been with Cathay Innovation for 8 years. I'm an investment director. We're a global venture capital fund based in San Francisco, Paris, Shanghai, Singapore, and Berlin since 2 years. So I joined the team actually in San Francisco, and I moved 2 years ago to Berlin to open an office focused on the German-speaking region and DACH. So we have a couple of portfolio companies so far, and we're looking to expand our footprint here. We mostly invest, we have 2.5 billion assets under management, and we mostly invest at Series A and B stage, early growth. And we're generalist investors, but we have 4 main themes, especially for our last 1 billion fund. And one of those 4 themes is energy and mobility. So energy is definitely like a big topic for us, where we're looking to invest into. Also thanks to our LP base, 1/3 of our LP base is made up by corporates such as Total, Valeo, Michelin, Pernod Ricard, Sanofi, a lot of different sectors, but many of them are interested in energy systems, and so we work with them also to understand which solutions in our portfolio can be a good match for them as well. Great, so very happy to be here with you. I'm gonna introduce you Nina. Nina is actually the co-founder and the co-CEO of Green Fusion. Green Fusion is a Berlin-based company that is focusing on leveraging AI-driven energy management systems for buildings. Very much needed solution. Before starting Green Fusion, Nina was leading the virtual power plant operations at Sonne, which is actually a prominent photovoltaic and energy storage company in southern Germany. And she's an engineer. She studied industrial engineering at TU Berlin, which maybe some of you might be familiar with. So thank you for joining us. Do you want to tell us maybe a few words about Green Fusion and what your company is doing more in detail?
Yeah, sure. So, hi everyone, good morning. Green Fusion started actually the startup life here at Merantix Campus, and still employees are dreaming about this nice AI campus, because we were founded in 2021, and basically what we are doing is that we have an energy management system, which is AI-driven, of course, otherwise we wouldn't sit here, for large residential buildings, multifamily houses with tenants inside, and our main aim is to reduce energy consumption and CO2 emissions of these buildings, and this will help our clients, who are mainly housing companies, to increase the energy efficiency of their buildings. And at the same time, all tenants benefit from our AI solution because we lower the energy bill in the end. And yeah, by now we are 50 engineers based in Berlin, and now sitting at in Kreuzberg, not here anymore. And we have more than 1,500 buildings live where our AI is actually running in the basements. And I'm also happy to explain a little bit more what it does in detail and where we see also challenges and potential.
Very exciting. Looks like it's having a real impact, your solution. I would like to introduce Ivan as well. So Ivan, he's a principal at E.ON, which is a division of E.ON, the large energy company, and he's mostly responsible for managing the startups in the portfolio. Before being at E.ON, he was a venture capitalist at NRW Capital, which is actually the 4th largest development bank in Europe. And he's actually been in the energy space for a very long time, since 2005. He has a lot of experience in the space. He worked initially at Enel in Italy, as well as E.ON. So he was also part of the corporate venture capital division at E.ON, that held different roles within those 2 companies. in finance, strategy, procurement, and so on. So a lot of experience seeing, let's say, various departments within those companies, and can really bring a lot of information about how the large companies are also like moving towards adopting AI solutions. Yeah.
Thank you for the introduction. Before starting, if someone wants to sit here, there's some places.
Don't be shy.
Don't be shy. Good. Maybe I can tell a little bit about E.ON. I mean, I guess you know the company as an energy company. We have 3 pillars. One pillar is about the grids, so the network. It's also a big part of our business. It's 75% of our EBITDA comes from the grid. Then we have the energy retail, so the customer business. We have 47 million customers in Europe and Turkey, so in the regions where we are present. And then we have a third pillar that is about energy infrastructure solutions, and yet more customer solutions for example, municipalities, cities. It's about the district heating and cooling network that we have in different regions in Europe. I work, as you were saying, for E.ON One, so one division of E.ON. We own basically a portfolio of digital solutions, it's B2B, for internal customers, so for E.ON customers, and for external customers. And we have 3 main activities. One is acquiring those solutions from startups, from scale-ups. We have majority stakes in those companies. Second pillar is about partnerships, and the third one is about our own software development, so some specific solutions for the energy sector.
Very interested in delving deeper. So I will ask the panelists a few questions now, but a lot of you have a wealth of knowledge and information about AI and energy, so please don't be shy. Prepare like a lot of questions. We would like to keep we would like to keep the conversation open and spend a lot of time jumping into like a lot of the questions that you might have, or even like if you have something to say that is not a question, like very happy to. I think this is a small crowd, open conversation, so feel free to jump in at the end of my question. Great, so maybe we can start talking a little bit about the impact of AI in the energy sector more broadly. Of course, like there's been like a lot of talking about AI and so on, but concretely, like what does it mean for the energy sector? Maybe we can start with you, Ivan. You have a more generalist view on this.
Yes.
So can you give us some examples of what are some of the initiatives at E.ON that have driven not only like efficiency, but also like sustainability goals and so on?
Yeah. No, thanks. It's I think a good question to start. So from a point of view, the AI is really revolutionizing the energy sector, and it's taken more and more importance as we move towards a more decentralized digital energy systems. I think we have currently, let's say, a big challenge because we are assisting a big shift from a centralized, stable energy grid to a more decentralized energy grid. What I mean with that? If you think about some years ago, you could say, okay, the demand and the supply of energy was stable. So supply was stable, it was not based on coal, gas, oil even some years ago. And the demand patterns were also very well understood. Now you have much more renewables, so wind, solar, coming to the grid. So introducing more complexity, more volatility. And I think AI is helping us to overcome those challenges. Now, if you think about, areas where I see that AI will have an impact, will have a role, I think one area is about, that I see massively, is customer interaction. So we are changing the way that we interact with our customers. With the rise of large language models, with the rise of generative AI, you see much more use of voice assistants, voice bots that are AI powered. Basically where most of the queries are answered by the bots and only the complex cases are handled by humans. This is one area The other one I would say it's load forecasting. I was telling before about the grid challenge. If you think about the low voltage part of the grid, you have a lot of electric vehicles, heat pumps, solar panels, batteries. All of them, they basically make difficult to forecast what's the load, what's going to be the load there. And we see a lot of applications basically in that area based on AI. Maybe a third area is about maintenance, predictive maintenance. So for until now, so we have, let's say, the challenge of kilometers of grids, and about the inspection of the grids to see if there are damages with cables, overheating, vegetation, also interference of the vegetation. There are now many more solutions based on AI, on drones, AI-powered camera with drones, that they do a much better job, up to 10 times more effective than traditional methods. And also, there are a lot of aspects to that. I don't want to monopolize the discussion, but of course there is also a sustainability component, for example, in there. We interference also with the vegetation, so doing it in a different way when we need to maintain those corridors clean, preserving the biodiversity that is also present there with the vegetation. And there is also safety aspects, because those drones take over also we have seen some of the jobs, for example, of removing something that is hanging on a cable. So there are drones with specific technology that can do that. So we don't need to send a person, physical person, for doing this kind of operations.
That's very interesting because you mentioned some solutions that might be very horizontal, like LLMs, customer support across all industries, but then there's also like very energy specific or like AI solutions that have been developed specifically for the energy market. So it's good to see that there's a mix of those that are having an impact on the industry. And maybe Nina, you can tell us a little bit about specifically how you're leveraging AI, but also like if you've seen anything else in the industry that's exciting and you want to share with us.
Yeah, I think I can totally follow up on your point that especially bringing more renewables into the system increases the complexity. And there we should use AI next to what you said, large language models for customer support, generative AI. But specific for the energy space, I think having more of those decentralized assets is really the key task for an AI. And just to also give you maybe an example from my Sonnenpass, what we did there, you said it, in the past we had coal power plants, we had gas power plants, and our aim is to get rid of those. And then what does it take to replace those? Actually, many thousands of small assets that can be in households or in multi-family houses, but all of these assets need to be connected, and it's literally thousands to replace a coal power plant. And this is where it needs AI to really, get real-time data from all those assets and to know when you can use them. And I think in the future we will have solar panels on the roofs in our cities, we will have large hot water tanks in the basement, battery storages, and the grid, as you said, we have EV mobility, everybody wants to charge, and you have to stabilize that. Otherwise, we need bigger grids, we need bigger power lines, and this will cost a lot of money. And the smartest way to avoid also the costs for the transport and grid expansion is to use the energy smart at the place where you produce it. And I think this is really where you can use AI. What we do specifically is we use reinforcement learning AI to do the job. Maybe I think there are also some experts. Reinforcement learning is one major methodology in the AI space, and how you can imagine this is that we use the way a child is actually learning. because you have an AI engine and it gets a reward if it takes a good decision, and it gets a punishment if it does something wrong. And you let them try out what is the best strategy. And this is actually pretty interesting to see, because we have these AI agents and they try out, okay, if I put on the gas boiler now or later, or do I use the solar energy now or later? And they have many, many options they can choose from, and they find the best strategy. And literally, I mean the best, because what has been done in the past, you would have an engineer, an energy engineer, they would look at the system and would say, okay, yeah, you need these temperatures, you have these limitations, and then you would program maybe a mathematical optimization. If this happens, then you do this. And the reinforcement learning agents, they really surprise us, because they choose more creative approaches in how they influence temperatures, how they use the systems. And we really see that this is better than the mathematical engineering approach, let's say. So I think there is a lot of innovation that can happen in that space, especially matching supply and demand from so many decentralized assets that are everywhere in the energy system.
That's actually super exciting to see. I think about a decade ago, I was doing my master, and one of the topics I took was renewable energy systems, and that's when I was exposed for the first time to demand management. And it's exciting to see that a lot of those things are happening. I'm sure there's like a lot more to do, and that's why we are here to kind of like disrupt or fund the disruptive solutions. But it's exciting to see that more and more of those solutions are actually hitting the market and so on. What about, I mean, what we see as a generalist investor, like investing across different business models, is that with Gen AI and foundational models and so on, there's like a layer that is still extremely data hungry on the foundational model layer. But we see that the application and fine-tuning layer, actually the data mode or the data requirement is less strong in a sense, because you are pre-training a lot of these models. So this is a trend that we're noticing across industries. But nevertheless, I think whenever you're building a new model or you need to like fine-tune it to your specific use case, data is extremely important. And I'm sure there's specific challenges in energy related to that. I mean, on one hand, you have like you're basically playing around with a critical system. So you need to ensure continuity of the service. You need to ensure that there's safety, as well as like privacy concerns and so on. Can you tell us maybe a little bit more? Even, do you want to tell us like how you're implementing that within E.ON?
Yeah. So you touched the point about the data. So data foundation is a very critical part if you want to have use cases. In the AI, you need this basically data that are of high quality data, that are also based on reliable state-of-art data architecture. I think any corporation, so E.ON as well as the others, if they want to be a playmaker in this field, if they want to be the playmaker in the energy transition, if they want to harness the power of AI, they need to have a robust data strategy. Therefore, for example, at E.ON, we have several projects ongoing to harmonize this data, make them fit for purpose, that would be also be used across multiple businesses. We want to have high quality data, to have high quality insights, or to have high quality recommendations. And then the question maybe is, what is high quality data? So we really get to the basics, right? So we need basically to define what is a high quality data for us. So we need to have standards around that to define. If we deal with data, huge amount of data, there must be also a governance around data. So data governance is also another aspect with standards and processes in order then to be in compliance with all laws and regulations in the markets where we are present. And I think another challenge is that for some applications you need also real-time data. So you need to ensure that the platform is also delivering, this data in the real time.
Yeah. What about? I mean, in buildings, I can imagine that the industry seems to be. I mean, from as an external point of view, like it seems to be very difficult to kind of like get access to like good quality data. How do you overcome that as a startup? And also like, what's the minimum requirement? Like, also like just to give it a concrete example, like how much do you need to actually be able to train such a model?
Yeah, very good question, because I don't know how many of you in your apartment have insights on what you actually consume electricity-wise or heating cost-wise. I think most of you know at the end of the year or maybe 1.5 years later. So the first step is really to get good quality data, and you need to have a connection layer to all the energy assets in the field. Let's say you have a gas boiler in the basement. You first need to connect to that gas boiler or district heating system, heat pump, and all of those, they have different manufacturers, they speak a kind of little bit a different language and have different data points. So the first step really is to get access to all these different energy assets. And then also, for example, we of course need sensor data. We need to know what is the temperature in the basement. We need to have electricity meter data, heat meter data, gas meter data. So there are so many meters that are measuring our consumption. And the first big challenge also is to really connect to all these assets and speak the language. And I think this is not only a startup-specific problem or challenge. There are many, many players that are concerned with that. Also, for example, the manufacturers themselves, Fissmann, they are, of course, providing data because they also see there's a value in the data their assets have. So, I don't know, maybe some of you also know about, there's a big initiative from Octopus Energy. It's called Mercury, where they want to have a Bluetooth for energy systems, because connecting to all these assets seamlessly is one of the biggest challenges of the time, and to really use AI. So I would say this is the first step, and we have our own, let's say, hardware that connects to all the energy assets in the basement or on the roof, and also collects sensor data, meter data. And then what you mentioned as well is the real-time data, and I think there, when we think about energy, especially, then we need smart meter data. And I think most of the buildings, especially in cities, are still very far away from having a smart meter installed that actually measures in a 15 minutes time frame what the consumption of the building is. And so nationwide or Europe-wide rollout of smart meters is really the basis for having AI in the energy sector.
If I can comment on that, as you are talking, came to my mind a very good example. Always think about, okay, we need to digitalize and to have these assets disconnected and so on. But if you think about the energy grid, it's a very old business. Many data actually are written on paper, on archives. We had one project at E.ON, one AI use case that also actually was awarded last year the Best of Technology Award 2024 from Wirtschaftswoche. That was about a platform in the health and safety space, where basically, based on AI, we were reading text about incidents that happened in the past, then integrating with other data sets, and then giving insights about potential incidents that can happen. So that's why I love AI as well. So it's so broad, and you always think about, but maybe sometimes it's just also data that are not there or have been there, and they are on papers, and you need to, translate them in order to have then a use case built on it.
Interesting, love that. I think that's there's a lot of things that we could do in theory, but then in practice we end up with these topics. And now I think also the government in Germany is doing a bit push for smart meter deployment, but it's still ongoing and slow, so we're going to see the real results in years from now. How do you think about scaling the AI systems? Like, I mean, like once you have the data and so on, I'm sure like the deployment, for example, that you did at Green Fusion for the first handful of customers is different than where you want to go in like 3 years from now, for example. How do you ensure that those AI models, specifically you're using reinforcement learning, they work across different use cases, different customers, potentially different jurisdiction, different, also like the data input will be different, right? How do you make sure that they don't break once you really scale?
Yeah, so I mentioned at the beginning, our AI is now running in 1,500 buildings, but of course in Europe there would be 200 million buildings that these agents could run on. And how do we make sure this is scalable? That's a very good question, because you have, for example, when it comes to grid interaction, very different legislations. You need to apply to different grid codes, you have different balancing standards, and so this you really need to make sure for each individual country. But what we try to use is also a technique that is well known in the AI space, is also transfer learning. So that, for example, now the buildings we have are trained, and the models, they have a knowledge about how to steer these buildings in a good way. And the next, let's say, I don't know, 20,000 buildings that will come can benefit from what the AI models already learned. So, and then we can use transfer learning also for buildings where we might not have the best data access, for example, and they already know from the other buildings, okay, an optimization in this way worked well for that type of building, so we can apply it in other buildings that are similar as well. So we try to use transfer learning to have scaling effects, and yeah, for the legislation part, I think that's a tricky bit, but there...
So I'm going to interrupt you just to ask a clarifying question. So does it mean that you have a model trained on each building, or do you have a model trained on a type of building? Or how many models are you actually running as a company?
So actually, every building has a model or an agent, and for this specific building you have a strategy. But you have metadata about that building. You know the installation, you know how many tenants live there, and you have information. And you can use this to apply it for similar buildings.
That's so fascinating. I think about the build, like, it makes sense. I mean, the buildings are so complex. You need a specific model for, of course, you can leverage transfer learning, but you need a specific model for each building.
Yeah, so...
I mean, E.ON is a huge company, right?
Yeah,
so like you're
I mean, that's what I would say. So
countries,
scalability...
so many business models and so on. How does that work?
Absolutely. So scalability and adaptiveness of the solution is really key for us. It also relates of one of our pillars of the ES strategy, that is about maximize business value from investments, right? So you want to have tangible benefits, you invest money, and of course you can reach it if the solution is scalable. So every time that we have a new solution, we need to be sure that is also scalable. What does it mean? So it means, first of all, is that this solution has, if you think about the matrix, about feasibility and benefits, we need to be at the upper right corner, higher feasibility and higher benefits of the solutions. So the first point that I would say is about data again. So we need to have harmonized data, structured data, where we can build all these AI use cases on it. The second point is about, so you are talking about the buildings, and you can have different type of buildings. For us is the question, if now there is a unit in one region and is building a solution that is AI based, and they have in their solution a definition of customer, a definition of asset, we need to be sure that this solution is also going to work for the other units. So I see there a lot of, ahead of us, a lot of coordination effort in order that is clear, documented, what we mean with that type of customer, what we mean with that type of assets, in order to avoid to build something that is not not then suitable for the purpose. Third aspect of it is about having modular AI solutions. As we operate in different regions in Europe, we're also subject to different regulations. So we need to be sure that reconfiguration of such solutions is also feasible and can be done in a fast, proper way.
Yeah. I mean, I'd be curious to understand we talked about several different AI methodologies, right? Like we talked about reinforcement learning, we talked about transfer learning, we mentioned kind of like Gen AI and LLMs for customer support. Are there other methodologies that, for example, you would consider implementing in Big Fusion or that you've seen in your portfolio? Anything else that we should think of? Because I'm sure that different methodologies will be applicable in different use cases within the energy market. Anything else to add?
Yeah, I would say for the use cases you also mentioned, we are using it as well. For example, when it comes to forecasting of renewable production or forecasting of demand. I would say machine learning techniques and also neural networks or deep learning are the way to go. You wouldn't consider reinforcement learning for that case so much because it doesn't make so much sense. But it's also time series analysis in most of the cases because we have sensor data and we have metadata, so it's a lot about that as well.
So you have a portfolio of solutions that you can apply depending on the use case. You touched a little bit on the kind of like regulation topics and so on, but maybe going a little bit deeper there. How do you ensure that you're deploying AI solutions safely and responsibly? I mean, these things are deciding when our devices in our homes are going to be turned on and off. I'm sure that there's concerns, around not only energy consumption but also like safety for the people and so on. How do you think about the regulatory aspect of that? This is like heavily regulated industry in different ways in different countries and so on. How do you build within this framework?
Yeah, it's a complex question. So let's say that we are a company, so it's a publicly listed company, so we need to be in compliance with the regulation. In this case, as you know, the relevant regulation is the new EU AI Act, which basically is evaluating the AI use cases on a risk metric from very low risk, minimal risk, limited risk, high risk, unacceptable risk. So at E.ON, I think at the moment we are more in the use cases of minimal risk and limited risk. However, there might be some cases where we go into the high risk. And what is, for example, as an high risk? If you have now an AI-based system in a control room of an energy network, that is telling you that maybe a component is not working properly, then it gives basically the signal to maybe switch off, let's say, that component, isolate that component. That is really critical part, right? The approach that we have taken is a human-centered approach. So the human, when we talk about these cases, specific cases that are critical, the human oversight will be there. It's not going to be replaced by, for this critical decision making, will be always a human being saying, yes, I agree with this and I act on that. It can also, there are different aspects of that. There is the aspect on the business side. There might be also, for example, aspects regarding the employees of the company, right? The way that we are maybe hiring people is just now AI-based. The algorithm send 100 CVs and says, okay, this is now the best fit in your team. No, we will not do it. There will always be a human doing it, reviewing those CVs. There might be issues about the review of performance of employees. And all of them, I think we will keep the human aspect. In addition to that, so this is the EU AI Act. In addition to that, we have some guardrails, some internal policies about the responsible use of AI. Now the point is, we need to be sure that the people are aware about AI, the potential of AI, and the safe adoption of AI. So it means that there will be, I think, an effort that is already started and they will continue as well in the next years about educating people. Different maybe use cases from maybe from E.ON GPTs or chatting, ask me anything, or chatting with your own data, to more business cases based on that. But there is this aspect as well of training people. I think we cannot, it's two aspects of the same problem.
Yeah, we have the same, because now we also have to act according to the European AI Act. And we also, most of the people are aware that they can use ChatGPT and other AIs in their daily work, but we also as a startup now use it to make our team more efficient, to educate them, and I think some are more aware of what data to put in and others are not so aware. So this is also part of our startup engagement, where we really want to educate our team. But when it comes to the customer side, they are concerned in the first place, because I mentioned most of the buildings are not digitalized at all. And now we come and tell them, okay, here's an AI, it can optimize everything for you. And of course, they have security concerns. They ask, okay, what happens if you lose internet connection? Is the AI going crazy then? Or what happens if you turn down a system and all people can't shower anymore or use electricity? And I think for us, it's a step to first start with a co-pilot. As you said, you don't let the AI make all the critical decisions from the beginning, but you rather have a human that first looks at it, understands it, and approves it. And then over time, they get more trust in the AI system and what it does and how it optimizes. And then they also say, okay, I watched it for a few times now, the co-pilot, now I'm fine with having the autopilot. But it's the same with autonomous driving. You could still, if you use the autopilot, you could say stop in a way and then just drive the car yourself. And this is the same way our energy AI works. And it's also nice to see, because we are working together with clients that are not so far in the digitalization, housing companies, and for them it's really cool. I see this co-pilot now and I use it, and they get step by step used to the AI and also lose their security concerns, because we show them, okay, we have measures in place that protect them.
Yeah, you build trust over time. It's interesting to see that on one hand you have the humans that are there to prevent the AI from doing problems, but on the other hand you have sometimes problems because of the humans that are misusing AI. So you're trying to address the thing from the two different ends. I would like to ask you a last question before actually opening up for the audience. What's the future of AI and energy in the next 5 to 10 years? I mean, we've talked a lot about what has been implemented right now, but what's your wild guesses for the potential in the next 5 to 10 years?
Yeah, I go first. So 5 to 10 years. So I think in the area of advanced predictive maintenance, we will see more and more applications of AI. We see a lot of potential in that area. The grid resilience, I think, will be a big topic. Mentioning before about these fluctuations of demand, fluctuation of supply. Medium voltage, low voltage part, households. I think we will see many more applications as well in the vehicle to grid, for example. So we have a battery that can then exchanging with the grid. And I think we will see a lot in the customer interaction part, and the customer solution part. I think today we are using AI I feel that we can still go to a customer with a much more tailored, much more customized solution. And I think there we are at the beginning. My bet is that these are some of the areas where we will see new AI, high added value AI use cases. I guess that maybe in 10 years' time we will realize, okay, if we add again the human aspect to it, the human touch, maybe it will be again a diversification point. And
yeah, I think you named the most important topics. And from my perspective, as a startup, of course, there's always the dream to become a unicorn at one point. And most of you know ChatGPT and DeepSeek, and I would hope for us in Europe as well that in the next 5 to 10 years, we also have something like this for the energy space. So I would hope we would have like a big energy AI that is really connecting all the different assets, steering, but also integrating with the end customers, letting you know when you need your energy, when you should use it, when you should not use it maybe. So I would hope that in the future there's also a big energy AI that everybody's using and integrating with. And maybe also looking to the VC side, I think it needs a lot of capital also to build something like this. And I would wish that there is also like a vision and trust in young AI companies that work on topics like this, so that they can actually be as big as OpenAI or all the big players. And yeah, I would hope that this is the future.
So basically you're saying a generalized model that understands not only the specific use case, but that understands like how energy assets work all together, how the grid works, and has a generalized understanding of that. That's basically what you're describing. Yeah.
So building is one part, the grids is the other part, the end user is the next part, and there are so many players coming together.
Let's hope we'll fund that. I'd love to open the questions to the audience, so I'll pass on the mic.
Just a bit on a meta level. Just I see a problem using AI and data. I see it like a chicken egg problem. Of course you need data, but to have data you need sensors. Sensors can be very expensive. You can only use the data you already had and the sensors you already had, especially in the example of residential building energy management. So what normally you should do is actually probably you have also a new building that is constructed, and someone built a lot of sensors and already using a mathematical model, respectively an algorithm regulation program behind it. So then you can use the data that the sensors already there. But the problem is, first of all, if you use an AI, a neural network, you don't really you have an idea perhaps what data you can use, but perhaps it's more useful to use data you didn't think about first. If you have a model, you already know what data you need. But if you build a neural network, you have to try what is useful to use. You have no idea at the moment. It's just a try and error thing, and that's for me it's the problem. Where do you get the sensors? Where do you get the data? And you need a lot of data. I think we don't have to repeat this to train your network. So it's really chicken egg. How do you start?
Very good question. And right now, I mentioned it before, we are a startup coming out of the Technical University Berlin, and right now we are in a 3-year research program, which is also funded by the German government, to exactly figure that out. What data points does it take to really have a good AI running on it? And right now, for example, we are testing whether we need 6 sensors in the hot water tank or 3, what the AI can do with it. So there will be some research about the perfect data setup, but also it's an illusion. You will never have the perfect data setup, and you have to work also with unknown.
Now, you can orientate on the already existing mathematical models that are there. There are mathematical models, they're also in use to manage energy management of buildings. You can use them, and from there just try other things.
You mean like using simulation data as an input for?
No, I mean like using the models as to get an idea what data could be useful for your neural network. But that's the point. I mean, what is useful for algorithmic mathematical model mustn't already be useful the same way in a neural network. It may be totally different data you didn't think about. They say, oh, why do they influence my energy management? But they may be important for a neural network to get some useful results at the end.
That's true, but also you mentioned it in the beginning, sensors are costly.
Yeah, that's the point. That's
Chicken egg, yeah. So you have to find a solution that a customer is also able to pay. So you can't tell them, okay, I need each heat meter and every pipe. You have to find a good balance there. But yeah, it's a good question to be figured out.
There's someone here.
My question's kind of related.
Okay, sorry. Go ahead. There's a fight here. We're arguing. My question is more related.
Yeah, I'm also curious about heating systems and sensors that you could use and data, especially on the temperature in the residential buildings, because usually you can't just install temperature sensors in all the private households. That's not very cost effective, and also you can't just do that in everybody's flat. So how, if you have a reinforcement learning algorithm that is optimizing for costs, how do you ensure that the temperature in the private flats is within limits of what you want? Especially since there's quite a complex relationship between the water temperature that you can measure in your heating system and the actual flats. It's not the same. How do you ensure the second to be consistent and to be in a good range?
That's a very good question, because we are currently also not installing sensors in every flat. There are also startups that do that, and we also cooperate with them just to see if it's a benefit. But I think the most cost-effective way is to start with the measurements you have from the central heating or energy system in the basement. And you can, by looking at the temperature that flows into the pipes into the building, you can already have an estimate how warm it's going to be in the flats. There is a relation, there is a formula, you can estimate that. And what is happening right now is that most of the buildings are running so inefficiently temperature-wise. They are just like install the heating system once, and it's a super high flow temperature, just to avoid tenants to call. So there's already room in just reducing and avoiding the losses, because what happens now is it goes out of the walls into the air, so you just lose heat you don't need, and there is the room for optimization. And in the end, I mean, we didn't have customer or tenant complaints yet, so the formula seems to work.
Okay, so just so I understand correctly, you basically have a thermodynamic simulation that simulates the effect on room temperatures based on the water outlet temperatures of your heating systems. And the way you control that model, that simulation model is correct, is by measuring the customer feedback, right?
Exactly, and you also see the temperature that flows back, so you can estimate a little bit how much energy was used on the way, yeah.
All right, thanks.
This gentleman in green has one first.
Hello, thank you for the talks, very interesting. I have a question, maybe it's a bit basic, but I'd like to understand it better. I like especially the part where you talked about how was the industry before the digitalization, and I could follow it, but I still have a question. So for instance, I come from science, from the PhD, and in there, the way that we estimate energy system is to create an energy system model or framework that we feed with data. And in my opinion, the best people are those who can develop a model that behaves more according to reality. So my question is, where does AI fit in this current way of doing things? Is it creating new models, or is it just creating new relationships with existing data? Because, for instance, we take in my institution, we used to take data from satellites. I imagine that there is room for improvement in the satellites, but for the short term, we're constrained by this data, and I assume it's okay. So I have a hard time imagining how AI will develop a energy system model for each region or each country or each district, and then a bigger one for a country and a bigger one for a region, or does it uses something that is already proven with even more data parameters to improve the results?
So maybe how we approach that, you're right. So typically to have an AI, you need to first simulate the environment pretty good, so that the AI can try out stuff and learn and find a strategy to act on. So this would mean we would have to simulate a building perfectly in a way, so that the AI can try, okay, what happens if I increase temperatures or reduce the volume flow or whatever.
Using an existing model.
For example, yeah, there is many building simulation models, for example. And what we see is that this is still too perfect, because reality looks different.
Right.
You have the perfect model, but then you look at real-time data and you figure out, okay, you underestimated certain parameters. And what we do now is really to collect data from the real buildings first and create a data-driven model for each component for that building. And then it's more realistic also to train an AI in that real data-based simulation environment, I would say.
So the AI in this case uses the input data and creates a framework that may or may not reflect deterministic physical equations, maybe. In the worst case, in the best case, it does, but it may also not.
Yeah.
Because of the human aspect of it.
Yeah, and it really uses the data, and sometimes this doesn't follow the physical assumption you would have in the beginning.
Yeah. Okay, I have a small following up question. I probably is a very basic one, but what is really an AI startup? Because you mentioned something about applying the right methodology to the right problem. So is it a startup something that creates this methodology, maybe tailors it, or does tweaks in existing AI code, or is it really creating a new version of AI that competes with OpenAI or this Chinese that is open source code? What does an AI startup look like?
It would be amazing to have both, I would say. Really one reinventing the whole framework, but what we do actually is we use open source AI frameworks for reinforcement learning, for example, and build applications for it. And that's what we do as an energy startup.
Something like a GitHub of OpenAI with some codes that can be used, put together.
Exactly, we use the OpenAI for energy and just put it into the application building, but there are other applications, grids and...
Yeah, but this same approach as you. So we are not now developing new, I don't know, AI models or so. So we are just more the users. And our effort is also to train some models on data sets that are specific to the energy sector. For example, here we have one example of one product that we have. It's conversational AI for customer call centers. So it's AI based, and we have a partnership with a startup. I would say it's a really AI startup, as we are calling it. However, their application, their model works for call centers, for logistics, for pharmaceutical companies, so it's very broad. And in that case, we decided basically to partner with them to take their algorithm and to train that kind of the LLM model on data for energy contracts, for gas contracts. And works pretty well.
Right.
Yeah.
Thank you.
One voice is the
I think I saw the question over there first. Do you still have the question? Just trying to follow the order.
Thank you very much. I'm Fritz Echternach from Global Logic. I'm mainly working in automotive software still. Also for us, AI has changed both what we are able to do and the way of working dramatically. On the way, we have roadblocks. So for me, roadblocks, for example, is data ownership. Not everybody is willing to share data because it's valuable. Another one is responsibility. If a car is forced to stop or not to stop, this might have dramatic consequences. So these are just two examples of roadblocks for me. I would be interested to hear about your main roadblocks. So if you could abolish three things, what will that be? Or what is blocking you?
I would say so. I'm not really now the expert from E.ON to answer you that kind of question in details. I think the big challenge I was mentioning before for us is about critical components, so critical infrastructure. So we mentioned critical infrastructure. We need to be sure there are no blackouts, that the energy supply, so the grid is working at any time. I think that's where there is a lot of thinking, and we said then we decided to have this human-centered approach, so to overcome that. And to be honest, I think it's not a secret. So we are a big company, 75,000 employees in different countries, and this harmonization, of data. So creating this data infrastructure that is fit for AI use cases is something where we will have to work hard, to get there.
Yeah, maybe I would say the first roadblock you mentioned is also a big roadblock for us. So really having access to the data, and for example, some energy device manufacturers are willing to share the data. You have the very innovative ones like Fissmann. They already implemented a layer like an API where you can just call their API and get all the data from their heating systems or heat pumps or whatever. But there are other ones, older ones, that are not so open-minded, and they also maybe either they don't have the capacity internally to provide interfaces to others, or it's a strategic decision. No, we want to have our closed ecosystem, and I think that is like you have to have a good collaboration with all these different manufacturers in that case.
I think we might have time one more question, and then I think he was first, and then the others we can maybe take them offline over breakfast.
Thank you very much. My name is Lorenz Kade from the German Energy Agency, and I'm wondering, so you were talking about the challenges in measuring and acquiring the data. What about the controllability? Is your AI agent able to control the devices, and does it depend on manufacturers, etc.?
Exactly, yeah. So we are able to control the devices, so we have the way back on the control from a system. But every system has a different definition again. So let's say in some you can tell them just increase the temperature. In others you have to say, use that formula to decrease the temperature, and you have to have the translation there as well, which is challenging, but it's part of the innovation we do.
Maybe just to complement quickly on that, so we have one of our scale-ups in our portfolio. The name is Gridix. Maybe you know that it's in the home energy management system, they have, so to say, intelligent box to control theirs, so decentralized energy resources. Could be a heat pump, could be a battery, could be wall boxes. And there you have basically the control part. And one of the USP, I would say, of GridX is the integration of their box with so many OEMs. So that is, of course, it's fundamental. You cannot do without.
I see many hands that were raised, but I got a signal that time is up. But thank you so much for the many engaging questions. I'm sure we will still have a half an hour to do some networking, meet each other, and ask questions to the panelists directly. Very nice to meet you. Thank you so much.
Thank you.